Okay, let's use our knowledge of differentiating by first principles to try some questions. So, in this question, we need to use first principles of derivatives to determine the derivative of y equals 5x squared with respect to x. Let's start off by writing out our derivative formula. We know that dy by dx is equal to the limit when h approaches 0, f of x plus h minus f of x all over h. Okay, we know our function, it's told us, is 5x squared. Therefore, f of x plus h basically means wherever we see x in our expression, we have to replace it with x plus h. So we get 5, and in our original function we have x, so we have to replace that with x plus h, and our original function has a squared, so this also has a squared. Now we could substitute that for f of x, and instead of x plus h, we could substitute this. Okay, so our derivative dy by dx equals our limit as h approaches 0, f of x plus h, which in this case is 5x plus h squared, take away f of x, which is 5x squared, all over h. Okay, let's start off by expanding this bracket. So our derivative dy by dx is given by our limit as h approaches 0, 5x plus h, x plus h, minus 5x squared all over h. Okay, so our derivative, as h approaches 0 is 5 brackets x squared plus 2xh plus h squared minus 5x squared over h. Now we can multiply all this by 5. So our differential as h approaches 0 is given by 5x squared plus 10xh plus 5h squared minus 5x squared all over h. Okay, now we could collect like terms. We've got 5x squared minus 5x squared, so they cancel, and so we're left with our derivative as h approaches 0 is given by 10xh plus 5h squared over h. We can now factorize the top, take out h as a common factor. So our derivative as h approaches 0 is 10x plus 5h on h, and these two h's cancel. So our derivative as h approaches 0 is 10x plus 5h. And because h approaches 0, this term effectively becomes 0 because 5 times 0 is 0. So our differential dy by dx is 10x using first principles.